Hello ladies and gentlemen, welcome to my YouTube channel. Today we are going to revise section C of Combined Science paper 2 that was written by November 2025 candidates. But before we dive into the revision, I have some interesting news with you all. If you are a student looking for support in maths and combined science for your June 2026 exam, I have got just the thing for you. My online lessons are starting on 1 November and I'm offering a fantastic opportunity to get ahead of the game. My online lessons will cover combined science from 7 to 8 p.m. and also mathematics from 8 to 9 p.m. The lessons are run from every day from Monday to Friday. And the best part of it is just $10 per month per subject. So if you are interested in learning more, feel free to reach out. Now let us get started with our today's revision session. So in the final exam, candidates are required to answer any 2 questions from section C, but we are going to answer all the questions from number 10 up to number 12 in this video. So number 10A, part 1, it was reading, bromine is a member of group 7. State any 2 properties of bromine. So we want to answer number 10A, part 1. So we are going to write here 10A, part 1. We are required to give the properties of bromine. So first of all, we mention the color of bromine. It is reddish brown liquid at room temperature. So we write it is reddish. It is reddish brown liquid. This is at room temperature. So this is the first property of bromine. Another property is that it is a strong and pleasant smell. It has strong and pleasant smell. So we talk about strong and pleasant smell. This is one of the characteristics of bromine. And then another characteristic of bromine is that it is highly reactive. It is highly reactive and toxic. So these are some of the characteristics of bromine. Let me repeat again. It is reddish brown liquid at room temperature. It has strong and pleasant smell. It is highly reactive and toxic. It can also cause severe burns upon contact with the skin. So these are some of the properties of bromine. We can now proceed to the second part of the question. So in the second part of the question, we are required to state properties which distinguish bromine from chlorine. So we need to create a table where we are going to compare chlorine and bromine, right? So you need to come up with a table like this. So we divide into 2. We write our bromine here, and then this is our chlorine, right? So we are saying bromine, it is reddish brown liquid, right? So they have different colors. This one is reddish brown liquid. And then you need to know that chlorine is not a liquid. Rather, it is a gas at room temperature. So it is a yellowish. It is a yellowish green gas. So this is one of the differences. Bromine is liquid at room temperature, whilst chlorine is gas at room temperature. And then another difference between bromine and chlorine, you need to know that the reactivity, it decreases as we move down the group. So it means that bromine is less reactive than chlorine. This one is less reactive than chlorine, whilst chlorine is more reactive than bromine. This is one of the differences between the two. And then another difference between the two, here we need to talk about the bromine. It is less oxidizing agent than chlorine, whilst chlorine is more oxidizing agent than bromine. Why? Because the reactivity, it decreases as we move down the group, right? And also we need to talk about the boiling and melting point. Bromine, it has more boiling point. So this one, it has more boiling point. So maybe we can say higher boiling point instead of saying more. So we say higher boiling point. Then this one, it has a less boiling point. Less boiling point than bromine. This one, we say higher boiling point than chlorine. So in summary, we are saying bromine, it is reddish brown liquid at room temperature. Chlorine is yellowish green gas at room temperature. Bromine is less reactive than chlorine. Chlorine is more reactive than bromine, right? Bromine is less oxidizing agent than chlorine. Chlorine is more oxidizing agent than bromine. Bromine, it has higher boiling and melting point than chlorine. Chlorine, it has less boiling point and also less melting point than bromine. So that is how we answer the second part of the question. So now we can now proceed to the next question. In the next question, we are required to state any two uses of bromine. So we are required to state two uses of bromine. This is now part 3. So bromine, it is used as a disinfectant. So when we are explaining this use, we say it is used as a disinfectant and also sanitizer in swimming pools, right? And also it is used as a pesticide. It is used as pesticide and also a fumigant in agriculture. Used as a pesticide and also a fumigant in agriculture. This is one of the uses of bromine. And then another use, it is used in the synthesis of certain pharmaceuticals. It is also used in photographic chemicals and also the production of dyes. So we are saying photographic chemicals. And also it is used in dyes production of dyes. So these are some of the uses of bromine, production of dyes. So in summary, we are saying it is used as a disinfectant and sanitizer in swimming pools. It is also used as a pesticide and fumigant in agriculture. It is used in the synthesis of certain pharmaceuticals. and also it is used in the production of photographic chemicals and also the production of dyes. So we now need to proceed to B part 1. So B part 1 is saying describe 2 chemical properties of group 2 elements. So when we are talking about the chemical properties, we are talking about how it reacts, right? So the chemical properties of group 2 elements, they react with acids to form salt and hydrogen. This is one of the chemical properties. The group 2 elements, they react with acids so that they form to form salt and hydrogen. This is one of the chemical properties of group 2 elements. And also they form ionic compounds with high melting and high boiling points. So they react to form ionic compounds. These ionic compounds, they are going to have high boiling points and also high melting points. And also we need to specify that they react with water. When they react with water, they are going to form hydroxides and hydrogen. So in summary, we are saying the group 2 elements, they react with acids to form salt and hydrogen gas. They form ionic compounds with high melting and boiling points. The reactivity increases as we move down the group. They react with water to form hydroxides and hydrogen gas. So these are some of the chemical properties of group 2 elements. And then lastly, we are now required to answer this question. Calculate the molecular mass of bromine, right? So the molecular mass of bromine, we are having bromine like this. We need to check on the periodic table the molecular mass of 1 bromine. So the molecular mass of 1 bromine is 80. Here we are having 2 bromines, so we are going to say 80 times 2 in order to get 160. This is going to be the molecular mass of bromine molecule. So we are done for the number 10. We can now proceed to number 11. So number 11, it is reading Fig 11.1 shows the apparatus used to investigate conditions necessary for rusting to occur. So we are required to identify with a reason the test tube in which rusting occurs. So the test tube that we are going to select is W. That is where we are going to have the rusting occurring. And then we are required to give the explanation. So let me explain. We are now on number 11, right? So on number 11, we mentioned that rusting, it occurs in W. And then we are supposed to give the reason. So you get your first mark by mentioning that rusting occurs in W. And then we are now required to give the reason. This is because water and oxygen are present. This is because water and oxygen are present. So these are the conditions that are needed for rusting to occur. So in test tube W, we are having water and oxygen, they are present, so they can react together in order to cause rusting to occur. So we need to analyze the test tubes in which rusting is not going to occur and why. So we are saying in X we are having anhydrous calcium chloride. So rusting is not going to occur because the anhydrous calcium chloride, it absorbs the moisture. And then in Y, the nail is boiled in water but covered by the oil layer. Rusting is unlikely to occur because the oil layer prevents oxygen from reaching the nail. And then lastly in Z, nail is coated with magnesium, which is more reactive than iron and will sacrificially protect iron from corrosion, which is known as the galvanic protection. So I have explained why rusting is unlikely to occur in X, Y, and Z. You need to know that for rusting to occur, we need moisture and also we need oxygen, of which these two conditions, they are there in test tube W. So that is why we are saying W is the one in which rusting is mostly likely to occur. And then on part 2, state the type of reaction occurring when a nail rusts. So this type of reaction, it is known as the oxidation. So when we are answering part 3, we are going to write oxidation. This is going to be our answer, right? And then we need to proceed. State N2 methods of preventing rust formation. So we are required to list methods of preventing rust from occurring, right? So this is our part 3, or part 4, right? So the methods of preventing rusting, we talk about the galvanizing. This is the first method, right? Another method, we talk about the oiling. Another method, it is known as the painting. Another method, it is known as cathodic protection. Cathodic protection. And then lastly, we are having the chrome plating or electroplating, right? So these are some of the methods of preventing rusting. I didn't exhaust all. We have the galvanizing, oiling, painting, cathodic protection, and also chrome plating, or we can talk about electroplating. These are methods of preventing rusting. And then let us check the last part of the question. So in the last part of the question, we are now required to explain how any one of the methods stated in part 3 prevents rusting. So I'm going to explain these methods. So first of all, we are having the galvanizing. So when we are galvanizing, we are coating iron or steel with a layer of zinc to protect it from corrosion. So here, let me just summarize. In galvanizing, right? In galvanizing, this is coating of iron by the zinc, right? We are coating iron by zinc. and this one is known as the sacrificial protection. The zinc is the one that corrodes instead of the iron. And then when we are talking about the painting, in painting, we are applying a layer of paint or coating which is going to protect the metal from the moisture and oxygen. So this is applying, we are applying a layer. We are applying a layer of paint so that we protect, we protect the metal from moisture and oxygen. So some of the methods I will just explain. And then the third one is the oiling. We are applying a layer of oil or grease in order to prevent the moisture from coming into the contact with the metal. And then on chrome plating, we are electroplating a layer of chromium onto the metal in order to provide a protective layer. And then on cathodic protection, we are using a more reactive metal like magnesium to sacrificially protect the metal from the corrosion. And then we need to proceed to the next question. So the next question, distinguish between a physical change and a chemical change, and then give one example of a physical change. So we need to create a table where we are going to be comparing a chemical change and a physical change, right? So this is the chemical change, and then here we are going to put the physical change, right? So in chemical change, we are going to have a new substance being formed. New substance with different characteristics is going to be formed in chemical change, but in physical change, no new substance is formed. So this is one of the differences between chemical and physical change. There is no new substance that is going to be formed when it comes to a physical change. And then another difference, the physical change is reversible, but usually the chemical change is irreversible. So these are two differences between a chemical change and a physical change. And then we are required to give the an example of a physical change. So example of a physical change, we can talk about the melting of ice. This is an example of a physical change. We can also talk about the boiling of water. Boiling of water. And lastly, we can also talk about dissolving sugar in water. And then the examples of chemical changes, we can talk about the rusting, burning of wood, and also baking a cake. These are examples of a chemical change. So we are done with the question that was on number 11 in November 2025. We are now proceeding to the last part of the question, which is number 12. Number 12, Fig 12.1 shows the apparatus used for the electrolysis of molten lead to bromide. So describe how the solid lead 2 bromide is converted to a molten lead 2 bromide. The question is having 1 mark. So for us to have a liquid bromine from solid bromine, this is going to occur through the process of heating. So we need to explain about heating here. So the solid lead bromide, it is heated above its melting point, resulting in ionic bonds between lead 2 ions and bromide ions, weakening, and the solid structure breaks down. So the resulting molten lead bromide is liquid, and the process is used in electrolysis. And then on part 2, give the correct chemical formula of lead 2 bromide. So lead 2 bromide, it is going to be like this. This is our lead and then our bromide. So this is the chemical formula of lead 2 bromide. And then on part 3, state with a reason the electrode A or B, which is the anode. So this one is the anode. The question is requiring us to state with a reason. So the reason why we are saying this is an anode, it is connected to the positive terminal. So this is the positive terminal, right? And then this one, it is the cathode. The reason why we are saying it is the cathode, it is because it is connected to this negative terminal. And then on B part 1, state N2 observations made during the electrolysis of molten lead 2 bromide. So we need to state the observation that occurs. So the first observation that occurs on B part 1, we need to explain what is going to happen at the cathode, right? And also at the anode. So at the cathode, that is where the lead is going to be deposited. So we are going to see a gray deposit of lead. We see a gray deposit of lead at the cathode. So this is how you get the first mark. And then we need to explain the observation at the anode. At the anode, we are going to see a reddish brown gas. So this reddish brown gas is the bromine. It is going to be evolved, indicating the oxidation of bromide. And then on B part 2, write the half equation for the reaction that takes place at electrode B. So let us see which one is the electrode B. This is our electrode B. We need to write the half equation at the cathode, right? So the half equation at the cathode, that is where we are going to see deposit of lead. So we write that lead 2 plus 2 electrons in order to have lead solid. So this is a perfect example of reduction. Reduction is the gain of electrons. So lead 2 plus is going to gain 2 electrons for us to have lead solid. And also, as we are doing our revision, we need also to know what happens at the anode. So this is what happens at the anode, the half equation at the anode. Here we are going to see oxidation. Oxidation is the loss of electrons. So when we are writing our equation we write like this, so that we have the bromine gas plus 2 electrons. So these are the half equations that occur at the cathode and at the anode. This marks the end of our tutorial today on combined science paper 2 section C, which is the chemistry section. Thank you so much for following me on this channel. Please don't forget to subscribe, like and share my videos. Stay tuned. I will provide section D